Welcome to Study Loop.
We know that the EMF epsilon is given by minus L di dt, where L is the inductance and di dt is the rate of change of current. So we can write this as follows. Since we know the inductance to be 4.8 times 10 to the minus 3 henries, and we have an expression for the current, which we can take the first time derivative of. So that's ddt, and the peak current is 0.68 amperes times cos of phi times t divided by 0.025 seconds. And so this simplifies to 4.8 times 10 to the minus 3. And if we do the time derivative, we get 0.68 multiplied by pi over 0.025 seconds times sine of pi times t divided by 0.025 seconds. And hence we have an expression for EMF epsilon. So if we require the maximum EMF in the circuit, epsilon max, we require that the sine term goes to 1. And hence E max, or epsilon max, is equal to 4.8 times 10 to the minus 3 multiplied by 0.68 amperes times pi by 0.025. And obviously the sine term goes to 1. And if we solve this, we get the maximum EMF to be 0.41 volts. Next, we wish to calculate the maximum magnetic flux. So we know the maximum magnetic flux is defined by the inductance times, in this case, the maximum current, I max, over N, the number of turns in the solenoid. And so we know the inductance to be 4.8 times 10 to the minus 3 henries. We suppress the units. The peak current we get from our expression for the current to be 0.68 amperes. And the number of turns in the coil is 400. And hence we get the maximum flux through the solenoid to be 8.16 times 10 to the minus 6 Webers. And finally, we wish to calculate the EMF at a given time t. So we know that the EMF as a function of time is equal to minus L di dt. And we've calculated this before above. So that's 4.8 times 10 to the minus 3 multiplied by this. And so if we simplify that expression, we get this is 0.41 volts multiplied by sine of 125.6 per second multiplied by t. So now we have an expression for the EMF at a given time t, having simplified the expression above. So therefore, we can calculate this EMF at time 0.018 seconds. And this is equal to 0.41 multiplied by sine of 125.6 times the time of 0.018 seconds. And hence we get the EMF at this point to be 0.316 volts. And so the magnitude of the induced EMF is 0.316 volts.